Right? So first thing we're going to do is see if we can isolate possible causes of this noise. Do the old famous tap test, right? Get in here and tap around. Look at there, got some sensitivity in that area. So Morning, this Terry here, D-Lab. This is part 2 of the Harmony 415 amplifier repair. This morning I'm taking over where that crazy tube amp theater guy left off. We had some low level noise. I'm going to investigate that, hopefully either eliminate it or make it a lot better. So it's a tech tip from D-Lab to you. Here we go. So here is the Harmony 415 amplifier chassis sitting up on some wood blocks. For the test, we still have the D-Lab audio test set, and now I also have a monitor speaker because the chassis has 2 speaker leads, right? So you're going to be able to hear it, and the audio test set will pull in the signal and bring that over to the scope so you can see it. So first thing we're going to do is baseline the current noise level. I've got the volume pots at 0, right? So hopefully you wouldn't have any noise, but we do. So let's fire it up, see where we're at. Alright, so first off, we know that these input jacks are substandard and they have to come out. These contacts become corroded and they cause noise. And they're also not the right type. We want to get some switchcrafts in there, right? We want to up the game. So those will eventually come out, but that's not what we're going to do first. First, I want to see if I can find a sensitive area causing this hiss and noise, right? So I'm moving things around. Look at there. Got something right there causing a little bit of noise. Tapping on this cap. It's a black beauty. It's generating a little bit of noise. But what I'm concerned with is when I'm simply moving these wires, I can generate noise. Okay, so that's not like a tube socket. That's sensitivity on some of the wiring. So let's cut to that. I think I know what's going on here. Should be a possible solution to this noise level. So first off, I want to mention that this amp has an upgraded power cord. So it has a ground, okay? And then if you follow your wiring over here, you'll see your filament wires right there, okay? And they're twisted coming off of the power transformer. Then they hit this tube, then they dance over here, hit this tube, that tube, so on and so forth down the line. But the thing I noticed immediately is we start out twisted, but then we just go into straight through wiring to each of these tube sockets. So as you remember, in the old school days, like Fender, they used to take and make twisted pair wires that went between the tubes to help cancel noise. That's not done here, and now you have a ground. So you can actually float the filament lines and put those balancing resistors on the end of the feed. That's what we're going to do, because right now, if you take a look at this last 12AX7, pin 3 is ground, and so is pin 9, right? So one half of the filament circuit is connected to chassis. And that's really not a good mix anymore, because now you have a grounded power cord. So the best way to take care of this is to put in the balanced resistors like Fender used and tune out that noise. And that's what we're going to do. Well, here's our twisted pair wire. Got a whole bunch of this that I zinged up on my electric drill. So pretty much I'm going to get in here, and this brown and black wiring, which was the old filament wiring, is coming out. So I'm just going to clip it by the tubes. We're going to take it all out and put in the twisted pair. And we're going to land 200 ohm resistors here at the 12AX7 to ground for the balancing circuit. So there are the 200 ohm resistors. One's right there going to pin 9. The other one goes under here with some heat shrink going to pins 4 and 5. This is the beginning of our twisted pair filament runner. So I'm going to go to each tube and then end up back over at the twisted pair coming off the power transformer. New filament wiring and balancing resistors are installed. I'm hooked back up to the test set. Here's my scope. Haven't changed anything. We're still at 20 millivolts per division. You see we still have a little bit of a noise signature here, but I do not hear a whole lot of activity out of that speaker. So it did get quieter. We're getting there. Now if I move around the new filament wiring, now see there's still some sensitivity in this area, but I don't think it's actually the wire. I think it's behind it here. Oh yeah. So I still got something going on with this cap right here. Watch when I'm tapping. What I noticed is this capacitor goes up here to this potentiometer and it's sharing the ground. And that's not actually soldered to ground, it's actually to a tab, and it has one of those rings in front of the pot providing ground. So if this pot's a little loose, you'd probably give a little bit of noise action on that cap. So I will try to solder that direct to ground, because you can definitely see the sensitivity right there. Now the other thing I noticed is pretty wild. If you go over here, you got your tremolo system, okay? So the tremolo goes into the grid circuit of the output tubes. So if you take the tremolo pot and turn it up, watch the scope. See there? That's when I'm playing around with the intensity pot, tapping on it. So it is a source of noise, because if you look at I think they call it J5. Yeah. So if you look at the schematic, there's J5, there's the intensity pot, and that goes direct to the grids of the output tubes. So that is a path for noise at all times, right? Because it does not switch out the tremolo circuit. So if I bring this up a little bit, tap on this guy, let's see what we get on the scope. So there is a little bit of noise that comes in, but you know what? I'm not really concerned with that right now so much as I am the ground on this cap. That's much more sensitive, and it seems like if I tap anywhere in that area, we're seeing it. So let's remove this cap, because it is a black beauty, and I will install a new 0.1 microfarad cap, but this time we're going to solder it to chassis. Alright, so I removed that crummy ground ring that they had in front of the pot to provide ground, and now it's directly soldered to the chassis. Also have a ground runner now going to the first pot, because it also has one of those little crappy rings, right? So let's see if it's made any improvements to our noise levels. Here's the scope. Still got a little bit of noise dancing around, but remember I had sensitivity here. Do I still have it? There is sensitivity, but not as bad. Right now I'm tapping on the cap. Remember the other one went kind of wild? This one's not too bad. But we still have some noise. Tracking it down. So the next question is, where is our next source of noise? Now this wire really makes her jump, see that? And that goes over to this 100K resistor that's hidden down here. I actually measured that resistor, and it's about 15K too high, and that used to go to the original filter cap. So it may be hurt, and that's exactly where this orange wire is going. It's making her jump. So a little more investigation to do, but we're getting there. I still want to change out these jacks, because I know they're the major violator, and they also share the crummy ground on the front panel with no lock washers. So before I go any further, I am going to go ahead and change these jacks. I'm noticing on the scope, if you watch, when I just barely touch this contact, see it? So that may be the sensitivity that I'm seeing. It's time for those to come out. Jacks are pulled. You can see there was absolutely no lock washers used. It was just contact against this surface and it's all corroded. So I'm guessing that this is a major contributor to the noise. So we're going to install 4 new Switchcraft jacks with lock washers. So I have the new jacks installed, and that really helped to get rid of some of the little birdies and spikes that I was seeing on the screen. But I still have sensitivity when I move this orange wire. Watch the scope. See it? So you know what I think? I think we got a bad connection right down here on this terminal strip. I think we just got a poor solder connection, and this is the power that feeds the preamp section. So I'm going to resolder that wire. So I was getting ready to resolder this wire, and then I looked at these resistors. You can see kind of a glob right there, some kind of maybe corrosion, something coming off the bottom of that resistor, and that's going right to that wire. So I'm going to change out both of these 100K resistors that feed the preamp tube, and I also changed out that old crusty looking 100K that was in the power supply that I told you was up to around 115 to 117K. So alright, let's change out some resistors. Well, it appears as though that was it. I changed out those 200K resistors that are feeding the plates of the preamp tube, and now my noise level is almost non-existent. Take a look at the scope. She's really looking good. Listen to the speaker. No more snaps and pops. So I had a couple wore out 100K resistors, I guess. It's pretty amazing. These are the original Harmony 12AX7s that came with this amp. I just checked them and they're up like 90%. These things are perfect, so we're going to leave them in. Success! The Harmony is pretty much noise free. So what's the tech tip I have for you? Take it one step at a time. Don't do too many things. Try something, see if it helps. If that helps, move on to the next stage. And eventually, you have yourself a clean amp. Thanks for tuning in. We'll see you again. D-Lab Electronics.